Okay, so in this video, I'm just going to recapture this idea of multiplying and simplifying radicals. One of the things you need to understand about a radical is it is the basic, how we have multiplication and its partner is division. Radicals are the partner to exponents. So we have many different types of radicals. So we have the square root radical, we have the cubic root radical, we have the fourth root radical, the fifth root radical, and so on. I can make this number whatever I want, okay? So what I'm asking you particular is, what on earth do these represent? What do they tell me? Well, here's what it is. If I have some number, so 5 to the third, okay? This number tells me how many times to write 5. And the answer to that is 125, okay? Now, there are many ways that I can multiply things to get 125. It just so happened to be that 125 is special because I can take 3 5s and multiply them in a row and get 125. Now, let's just say I know nothing about that. Let's pretend that I know nothing about this idea of 5 cubed, and I give you this number 125 out of nowhere. And then I ask you a question. Can I multiply something by itself a certain amount of times to make 125? Well, sure, I can multiply 2 things by itself to make 125. They're not going to be nice numbers. They're actually going to be never-ending decimals. So when these questions are asked, people are going to be more specific. Well, what do you mean by multiply? Well, how many numbers do you want me to multiply together? And that's what a root essentially is telling you. It is asking you, how many numbers does it take to multiply together, or does it want you to multiply together to create the number that it's asking? So in this case, if I wanted to ask you, what number, what base, okay, do I multiply by itself 3 times to make 125, I would say to you, give me the cubic root. So I'm asking what number right there. That 3 is telling me what number multiplied by itself 3 times because it is placed with a radical. If it is not placed with a radical, it means nothing. So this 3 on the radical is asking what number multiplied by itself 3 times makes 125. There's many ways we can go about this. And one of the ways that we can go about this is we could use the calculator very quickly. And if we type it in the calculator is going to give us 5. So this told me that I use 5 3 times. Okay, so if you notice that whatever this number is, you better make that the exponent. That is this number's exponent to create 125. So with that being said, we can simplify using this method. Well, what happens if I take 250? Well, how did I create 250? So how on earth is 250 created if I have this cubic root? Well, if I type this into the calculator, I get some crazy decimal. And therefore, it's an irrational number, and I can't be specific. I can't actually get the number 250. 250 cannot be created by multiplying a number by itself 3 times. It is not possible. There is no number in this world that you can say exactly will multiply together to make 250. You could estimate a number multiplied by itself 3 times and then get near 250, but you will never, ever, 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 ever be able to get a decimal number that you can have that will multiply to 250, because the decimal that you will need is actually an irrational decimal. It's an irrational number. So how do we simplify these? Well, you simplify them as you go, okay, well, is there some factors? Is there something in here that gets multiplied by itself 3 times within the structure of the 250? And the answer to that is, well, okay, well, how do I make 250? One of the ways that most people use is the idea of prime factorization. Prime factorizations are unique to every number. So if I break 250 down, well, I get 125 times 2. 125 I can break down. And breaking this down, I get 25 times 5. And then I get 25 is 5 times 5. So what I now have is the prime factorization. So what I can now say is I'm going to write this out now in its cubic form underneath. So the cubic root of 2 times 5 times 5 times 5. So is there a number being multiplied by itself 3 times? And the answer is yes. I could rewrite this as 5 to the third power. Yes? So the answer to this is 5 goes outside. That's the number, right? Multiplied by itself 3 times. And what I'm simply left with is this 2. It's a remainder, much like you would when you do division. You would say, I have a remainder of this. Well, we just leave our remainder number underneath. So to this video, very quickly. This one is not cubic roots. This one is square roots. And it involves multiplication. So what can I do? Well, if I have identical roots multiplying each other, what I can do is I can write them together as multiplication. So what I notice is this is 5 times root 8. This is 6 times root 12. What I can do is by the commutative property, because this is all one big strand of multiplication, commutative property allows me to rewrite things in any order that I want. So I'm going to choose to take the things that are not next in radicals and put them next to each other. So I'm going to go 5 times 6 times square root of 8 times the square root of 12. There's my commutative property at its best being used. Now, the question is can I combine this 8 and 12 into one radical? Because I know I can combine 5 and 6 to make 30. There we go. That's easy enough, right? But the question is can I do this square root times this square root? And I'm just, for this video's sake, going to let you know that the rule does allow for that because multiplication allows for the combination of these. Because these square roots are created by the multiplication of two numbers, and it's asking you simply what numbers do you multiply. Well, if I take this number, multiply it by this number, it's not going to break that idea apart. It's just going to make a different number. So now, what I'm going to suggest to you is that you don't actually multiply them. Because think about it, when I break down square roots, I still have to do the factor tree, the one method that I'm just going to use for this particular video. Okay? I'm still going to have to break the numbers down. So why make the number larger and then break them down when I can just start basically mid-branch and say, okay, I have this 8 times 12. Well, start mid-branch. Okay? Instead of multiplying to make this big number and then breaking them down into two new numbers, let's just start mid-branch and start breaking those numbers down. So I have 4 and 2, 2 and 2. This is 6 and 2. This is 3 and 2. So now a square root asks you the simple question, are there numbers multiplied by itself? Is there a pair of two numbers? And if there is a pair of two numbers, I don't want both pairs. I just want to know what is that number. So here we go. So this becomes 30. All right, so square root, can I put a pair? Well, I have a 2 and a 2. So this is 2 times 2. Then I'm going to multiply it, okay, by the next thing. So I have another 2. Okay, I have another 2. So I'm going to do this in order. I have another 2. And then I have this 3. So times 3. So the goal is to find pairs. So here's a pair, and here's a pair. Why is it that I only pull one out? Because I don't want to know what 2 times 2 is. I literally wanted to know what's the number that I'm multiplying by itself 2 times. That's the question that's being asked. That's it. So what number is being multiplied by itself 2 times? 2, the first one. So this becomes 30. We pull a 2 out. Okay, I have a 2 being multiplied by itself. Do I have any others? Oh, well, I've got another 2. So I write 2 again. So I'm not writing 2 times 2 here. I am taking this one in here and this one and putting it there. Now, do I have any other pairs? Well, I have the square root of 2 and 3. Nope. So they just stay put underneath the square root. However, at this point, we will combine them into one number. I won't leave this as 2 times 3. I will take the 2 times 3 and multiply it to make it 6. Now, the last step you have is to clean up the outside, which is 30 times 2, which is 60, times 2, which is 120. So the answer to this is 120 root 6. This would be considered your simplified form. So again, square roots, it always requires you to multiply the numbers outside, multiply the numbers inside. However, it's always usually in your best interest to not really multiply the numbers. Just show that you are multiplying them, showing the property, break the numbers down, find the pairs, pull the one out. that you're saying is multiplied by itself, and then you multiply it outside by what is ever currently there. And that's how you simplify a radical that uses multiplication.